bands of energy. The first is known as valence band and the other is known as conduction band. Okay, now electrons reside here. Electron resides in the band. Okay, and band energy increases this way. Energy of the band increases in this way. So one is from the logic gate, which we have already discussed, and if you have revised it thoroughly, if you have practiced all the questions that I have given you, then well and good, you are ahead of many people. Okay, so yeah, that's a good thing. And the other part, other question come from another part of the chapter, which is actually the semiconductor, and we are going to begin with that. Okay, so let's begin our discussion with semiconductor. So as I can name the guess, the name says it is semiconductor. Semiconductor means it is half conductor and half non-conductor, that is insulator. So what is the use of semiconductor? Okay, before getting into what is the use of semiconductor, I want to make something clear. Okay, what is that? If I say conductor, then I mean conductor only. I mean conductor only. That means it is capable to transmit, or you can say transfer heat and electricity. So anything that can transfer heat and electricity, that is known as conductor. If I talk about insulator, so what does insulator means? So whenever I say insulator, I mean insulator only. Okay, I mean something which is non-conducting, that means it is not capable to transmit heat and electricity. Okay, but the moment I say semiconductor, I make it so clear to you that semiconductor means it is showing the property of conductor and it is showing the property of insulator as well. Now at a single time, how is this possible that a same material is conducting electricity and is not conducting electricity? That is the key point here. Semiconductor behaves like a conductor and behaves like an insulator at different condition, whether at different temperature, at different pressure, etc. and all. Okay, so I'm repeating this again, that a semiconductor behaves like a conductor and an insulator, not at the same point, but at different conditions like different temperature or different pressure. Okay, so what you should know is that the conductivity of a conductor, okay, if I say that sigma represents the conductivity, then conductivity of a conductor is definitely greater than the conductivity of an insulator. The conductivity of insulator will be least because that is not capable to conduct anything. And in between them lies the conductivity of semiconductor. And this is the only thing which we are going to study in the entire chapter. Okay, so how can we control the conductivity of a semiconductor? Because right now I mentioned that a semiconductor behaves like a conductor and an insulator. So that is up to me, that how do I want to make it a conductor and how do I want to make it a insulator. So I can control it. Okay, let me write it down, that conductivity of a semiconductor can be controlled by temperature and doping. I hope you are already aware how the temperature can regulate it. If you remember, then we had the formula of resistivity, that resistivity is equal to R naught 1 plus alpha T. Remember? So this was the formula of resistivity, and sigma, that is conductivity, is equal to 1 upon resistivity. So this is the formula of how I can get that the conductor's conductivity is dependent upon temperature. Okay, and okay, so definitely one thing is observed, that if I will increase the temperature, the resistance is increased. Since resistor is increased, the conductivity is decreased. It's clear to me. So in the same way, if a semiconductor behaves like a conductor, I can say its conductivity can be controlled by temperature and can be controlled by doping. Now this is a new term for you. Okay, maybe it's a new term for you. What is doping? Doping basically means that something is being mixed here, something is being added here. Okay, so repeating it again, I will be making a broad discussion on this, so no worries now. Just note it that conductivity of a semiconductor can be controlled by the temperature and doping. Okay, I hope that is clear. Well, before getting into how can we actually control a semiconductor, how can we make a semiconductor, let me first explain you something, okay, which is known as the band theory. Before band theory, let us know what is orbit theory. So what are we talking about? We are talking about semiconductors are basically elements. Okay, and elements are made up of atom, and atom consists of electron, proton and neutron, where electron orbits around the nucleus. So if I say that this is my nucleus, okay, you will find that if this is my proton here and my neutrons are here, so around them we are having various orbits. Okay, and on this orbit and in this orbit the electrons are orbiting. We call this as orbit theory. Okay, orbit theory says that electron revolve around the nucleus. Okay, but in our earth, or in our let us say in our entire knowledge, we do not have a single theory for any particular topic. Okay, for a particular topic, a lot number of theory exist. So the first theory is orbit theory, okay, which we already know from the concepts of modern physics. Okay, the other theory is known as band theory. The other theory is what? The other theory is band theory. So the band theory says that electrons do not revolve in the orbit that is present around the nucleus, but instead they are present in bands. They are present in bands. So do band theory exist for just semiconductor? Okay. Do it exist only for semiconductor? Only for semiconductor? Your answer must be no. Okay. It do not only exist for semiconductor. It exists or is applicable for all the elements. It is applicable for conductors, it is applicable for insulators, and it is applicable to our semiconductors as well. Okay, and since we are discussing the topic of semiconductor, we are getting to know it. Okay, so this band theory is basically based on energy. This is based on energy. Okay, according to the band theory, every atom has two kinds of band. Every atom, according to it, atom has two bands of energy. Okay, the first will be known as conduction band, and the other one is known as valence band. So how do they look like how are they appeared? So if I say that this is my line of margin, you will find that my valence band are close toward the reference. Okay, and they are like this. Okay, they are like this. Okay, and over the valence band we have our conduction band like this. Okay, over the valence band, what do we have? We have our conduction band. I hope that makes sense, that is clear. Okay, do I need to repeat? Well, let me repeat it again. That atom consists of different bands of energy. Okay, basically there are two bands of energy. The first is known as valence band and the other is known as conduction band. Okay, now electrons reside here. Electron resides in the band. Okay, and band energy increases this way. Energy of the band increases in this way. So what can you refer from here? Okay, I can say from here that energy of valence band is less than the energy of the conduction band, or you can say conduction band is more energetic than the valence band. I hope that is clear. Okay, so this is my conduction band, this is my valence band. Okay, electrons are placed here. Okay, and electrons may be also present over here. Okay, and you can see that between the valence and the conduction band, that there is a gap present here. Okay, this gap is represented by Eg, because this says this is the band gap. Band gap basically refers to the energy gap between the valence band and the conduction band. Okay, I hope this is clear. Okay, so if I talk about the valence band, if I say that my valence band exists from this to this, okay, can I say that this is the outermost band of the valence band? So I will say EV max. Why I will say it is EV max? Because this band of the valence band has the maximum energy. Okay, this band of the valence band has the maximum energy. Similarly, if I talk about this, I can write this as EC, because this is the band of conduction band. This is the energy band of the conduction band, and this will have the minimum energy for the conduction band. For the conduction band also the energy increases in this way, right? So this will have the minimum energy of the conduction band, and this will have the maximum energy of the conduction band. I hope that is clear. Okay, so I can say that Eg, that is the band gap, or you can say the band gap energy, that is equal to EC minimum minus EV maximum. EC minimum minus EV maximum. I hope that is clear. Okay, so this was something which I can call as theory. But what is actually valence band and what actually is conduction band? Let us discuss this. Okay, basically conduction band and valence band are infinite energy levels. These are infinite energy level which may be empty or may be filled, filled with what? Filled with electrons. Filled with what? Filled with electrons. I hope that is clear. Okay, so conduction band are infinite energy levels which are either empty or they may be filled with electrons. Okay, so here exist, okay, these electrons are the free electrons. These electrons are the free electron. You remember we say that in conductors have free electron which carry the electricity. So the free electrons are present in the conduction band. You can see the name as well, conduction band, the one which is which is capable of conducting. Okay, and therefore I can say that the current flows due to this electron. Current flows due to this electrons. Okay, I will really ask you to please focus on these 2 points about the conduction band. That here the free electron exists, which are capable to flow or conduct, due to which current flows due to this electron. Okay, talking about the valence band, these are also infinite energy level. These are also what? These are infinite energy level. Okay, and these are always filled with the electrons, always filled with the electrons or hole, electrons or the hole. Oh my god, what is this new term hole here? Well, hole are basically empty spaces for electron, empty spaces of electron. Okay, let us say that here there was an electron. Okay, the electron just moved away, so you can see that this is left empty. This is known as hole. Okay, so for whenever from a place electron goes away, that place becomes empty, the place becomes hole. Okay, so I hope it is clear that valence band are the one which are infinite energy level. These are always filled with the electrons or holes. Okay, now these have the bonded electron. These are the bonded electron. Now what does bonded electron means? So right now I said that conduction band have the free electron that are capable to conduct the electricity. The electrons of the valence band are not capable to conduct the electricity because they are in bonded state. Okay, they are in bonded state, due to which I can say current cannot flow due to this electron. Current cannot flow due to this electrons. Okay, I hope that is clear. Okay, sounds good. So let me repeat it again. Conduction band are the infinite energy level which may be filled with electron, which may not be filled with electron. If electrons are present there, so the electrons will be free electron and they are the one capable to flow the current here. Okay, but if I talk about the valence band are the infinite energy level which are always filled with the electrons. Okay, and if electrons are not there, holes will be present there. Okay, therefore I can say that the electrons are bonded here. The electrons are bonded here, and due to the bonded state of the electrons, okay, they do not carry energy, they do not carry current at all. Okay, so I hope this is clear. Okay, now let us if I just said
it's lack of personal attention. With one-to-one mentoring, every doubt is addressed, every concept is applied, and real improvement begins.